Yeah. First I was going to have a tech talk, but then people said that they expected a philosophical one, so now it's going to be a bit of both. Well, the title isn't really what the talk should be about. I'm not going to talk about how relying on cloud services is getting us frustrated, because it's really emotionally difficult for an operations guy to tell whoever that Amazon is down and we can't do anything about it, because when you don't have your infrastructure in control over your infrastructure, it's sometimes really difficult to face downtime that you can't do anything about. And it's not about how the speed of development and all the progress that we've made in terms of getting up to out with the releases is making developers use more and more abstractions that mean that nobody has any idea how many resources they're using or how difficult it is for operations to provide for everything that developers would like. Well, software doesn't know about limits that exist in the physical world, so it's about what we did last summer and the summer before that. Well, we basically went from the ad hoc development where processes ran in screens and debugging was done using print statements, and it was really a fast turnaround time because developers could just SSH into machines, change the code there, restart the processes if needed, and see what was going on when things didn't go like they should. And how we basically grew up as a business by adopting practices that we really should have done before, but they somehow slowed us down, and I'm going to talk about that mostly. How all the lean and extreme programming and all these practices made us in a way much faster and much more predictable. And from the business side it was great because people could plan ahead much more reliably, but from our side it was sometimes really difficult to catch up with developers because we made them respect certain practices, but that didn't work out too well sometimes because we took away some of their ability to do dirty things. So most of this talk will be about how we migrated to CoreOS to help us manage some of the legacy services that now run in Dockers, and it's really difficult to do dirty things within those Dockers. You have to go through the entire cycle of basically committing to a repository and then building it, and we've been skipping testing for a year now because it just takes too long in an emergency, but we try to test when there's time to test. And the main problems that developers have is that they don't really see what went wrong, and that means we had to start using more complex logging tools to see what was going on, and that brought extra problems when these logging tools became so complex that sometimes the logging tools didn't work, and it was difficult to explain to developers that their code might be working but logging doesn't. We've had both us and other people had problems when logging stopped working and then the application stopped working because the logging infrastructure would block it. And the second most difficult, well, actually I think it was the most difficult thing, was to create a reliable staging environment for developers to work on. We still don't have a tool that would allow us to get a part of the production database and give it to developers to work on, to run sensible tests on it. Our databases are they're not really big in terms of gigabytes or anything, but being complex, we still haven't given them tools to build a staging environment easily and quickly. And the last problem is that in those Dockers where processes now run, most of our infrastructure is Django applications running in Dockers. People just struggle with what's going on when things don't work, and then they run it on their own computers or they run it in staging environments that they build, and it works there. And it's sometimes really difficult to figure out what's wrong, whereas before you would just attach to a screen, change the program to include a print statement or a logging line, and you would see the results immediately. The whole build cycle now means that sometimes the conditions that made the code fail are just not there anymore when you try to test. And then eventually, after searching for what we should work with, we started using CoreOS. It was, as always, it was just testing it, and then suddenly it became production. And it works quite well, but we don't have enough machines. So sometimes things go really bad. But we now don't let anyone change code in production and restart anymore. So yeah, we have a lot less. We're much more predictable now, and we haven't had a disaster in a couple of months now. Well, no, we had one just.
Disaster.
Yeah. The problem is that these tools are becoming so complex that. The last event we had was when etcd and the whole cluster was up, but all services were down, but we could see they were running, but they weren't available because the load balancers thought they were down and so on, and we had to restart the whole thing, and this was a really frustrating experience. But in a way we were also happy about this because none of these, if we hadn't gone down this path, none of these would have been enforced, and we would still have developers shoving print statements into code on production, which is really bad because they often didn't commit back to the repository and things went out of hand quickly. And well, this is just a list of things that developers constantly complain about. They don't really complain. They're happy to oblige when you tell them you have to do things this way, but being a developer myself, I can see what they're after and how they don't get it. The thing that bothered people who worked before was the turnaround time that they had to cope with. There was it used to work really quickly because you could change things and test them basically in production because we didn't have staging, and we didn't want to do that anymore. But now things work slower than you would have if you would have like the build cycle makes things really slow compared to before, where you could just restart things and see them work or fail immediately. We still have a bunch of legacy code where you can do that, but we're moving it to infrastructure where you can't, just to force developers to work with more predictable processes. Well, eventually we had to let go of the position. Like, we had to let them do the dirty things when things broke down, and they said, well, maybe we shouldn't enforce the practices that we are trying to enforce, and right now we're only half enforcing them, and whenever something breaks the way it shouldn't, we just run the way we used to run in legacy. We change the configs of the front-end load balancers and test things the old way, which is really sad to see because there was so much work done on building tools that would allow these people to work with the new infrastructure that would make them use the, how do you call it, the lean way. Now it's just a big mess, and what we're struggling with is we should have many more people just building tools for engineers to use, so they could have the access, the access that they need to runtime data and everything. And yeah, we should have more hardware because larger clusters tend to be more stable in our experience. Yeah, it was difficult because we made things leaner. We made, actually, what I was happy about the most is that there were a lot less unpredictable alerts and a lot less flapping of services. There was a lot less work to be done on emergencies and fires, but there was a lot more work to be done on helping developers figure out what was going on, and a lot more of those fixing those bugs that don't really exist when you look at them. It was supposed to be faster and cheaper, and it is more reliable in a way, but it's not cheaper because we need many more machines, and we're still working. Most of our work is still going into building tools for developers, like giving them Kibana or to check out Logstash, and building logging things, working with logging infrastructure that sometimes breaks because it's so complex, and developers aren't really used to working with those kinds of systems, and those kinds of systems require a lot of hardware to work the way they're supposed to work, like having real-time view of the systems requires a cluster that can process so many events as we're generating and so on. And this is not cheaper in any meaningful way, except in the way that you could actually develop faster if you did it right. But I don't think we did. Yeah, not everything was bad, and some of the things that we did made a great difference in making things go smoother and faster. Yeah, this is the thing I was really happy about. We used to have alerts all the time, and my colleague was really upset about that, and I was used to it because that was the way we started. Most of the alerts were really just restarting services, which might have been done automatically altogether, but we always wanted to see why things went wrong. But right now things do happen automatically. We don't even register anymore when things break down and come up by themselves. But sometimes the whole cluster goes down. For most of the time it's for reasons that we can figure out, but sometimes no. And it's, well, restarting a cluster is always a bad thing. These things are like designed not to fail, and we make them fail all the time. Mostly it's because we're always walking the thin line between too little machines and too much load, and the problem is that the cluster where we work most is much smaller than it's just 3 machines, which is the minimum for etcd to have quorum. And we have a larger cluster for testing, but we don't really need it because the applications there are really lightweight. Yeah, for learning about these things, we spent a lot of money and a lot of servers, and we still need to do the things that I mentioned were broken. developers really expect us to build them staging environments where they can test the code and where they can reproduce the bugs, which currently they can't because the databases are difficult to provision into staging because they're too big, and we would need a tool that pulls out the relevant parts and allows them to test. Yeah, and our system monitoring used to be just Nagios with mostly tests that we ourselves wrote and some of the built-in tests, but now we're using all kinds of external services. Most of the health checks are now handlers on HTTP, like they should be, but this means that we're much less aware of what's really going on machines, and maybe it's not really that important what's going on, but we should really have a bigger cluster if we want to just ignore some of the problems that are occurring. I would say it was a step forward, but it was a step in the dark. We had to learn, yeah. We had to learn how to cope with these. It was easy for operations because this does everything for you, but it was really difficult to just say to developers, well, you can't do this, you'll just have to commit and build and wait until it provisions, and well, then we just built those tools that allowed them to manually start Dockers with shells in them and do things the ugly and usable way. Yeah, and we got a bunch of nifty tools that allowed us to see really neatly what's going on, but not really have fine-grained control of what's going on. Yeah, this is a slide about what happened a couple of months ago. Of course, all of this is experimental. There is a stable version of CoreOS, and it is stable, but the way we're using it doesn't make it any more stable than it should be. Eventually, having to restart the cluster was scaring us, basically, because restarting a cluster because you don't know what's going on is the worst thing you can do, like the worst thing you want to do. Yeah, we learned that larger clusters tend to handle partitions better because somehow quorum of 3 machines is just not enough for production environment, and we should have at least 5. But we don't need 5. We don't have a workload for 5 machines right now. But the best thing about this is that this is all legacy. The new services that we're designing are built with the cloud in mind and can handle this much better. Well, eventually we made developers understand what we're trying to do and shown them that we're trying to help them. We're still working on the tools that they need. Most of these tools allow them to break the rules that we designed that would make the process more predictable, but apparently they need them still for all the legacy stuff that's running there. Sometimes it was difficult even to support, like getting Django applications to forward logs to Logstash and so on. This is really easy to do, but it's really difficult to do right so that it works when it's supposed to work, when things break down. And the best thing about it was that we pivoted and started a new project where we did things much better. the applications were designed from the ground up to run on machines that can go down at any time. That's not entirely true, of course. We still try not to waste money, but having larger clusters is now not considered wasteful anymore. And yeah, maybe we learned that developer time is important, and also developer frustration. And sometimes even we get some slack by telling people we're frustrated about having a small cluster is now enough for us to get a little bigger one. So maybe it's not that expensive after all. We used to actually be happy or even proud of getting things really cheap, but well, when they break down and you try to estimate the cost of all the people working on that and being really upset about these things, you see that it's not that expensive to run in the cloud and have a large cluster that can scale basically in real time. And if you think you want to enjoy this, you can apply for a job. We're looking for infrastructure engineers right now. Yeah, you look like that after the day. Or at least you feel like that. And yeah, if anyone really wants to work in an environment like this, I'll help him. And I think this is it, so we can talk about things.
So, questions?
Questions?
First of all, I want to say thank you for this very honest presentation. I don't think I've heard the presentation that was this honest in a long while. I have noticed that you're using a couple of tools that were basically equivalent, like etcd and console. And I'm wondering how many tools have you used, and what was the cost of having so many tools? And how do you cope with that?
We had to make a choice, and we didn't want to. We didn't know them well enough. So then we tried out one tool, and it became production. And we tried another tool, and it became production. And that way, well, eventually you end up with a whole bunch of services that you have to maintain. And even though you're trying to migrate to those that you see that are better fit, you still have to maintain the legacy. And we've had a lot of that going on. We still run Hadoop cluster that we shouldn't be running at, but it'll run.
So you have Zookeeper as well?
Yeah, we have, of
so
course.
Everything that's running on Raft or Zap, basically.
Yeah, but that's just a piece of legacy infrastructure now. It has to run it has to run until the last Christmas, but it's still running, so you know how that works. And we are deprecating old stuff and trying to get rid of it, but the way things turn out on the business side is that people still pay money, and that means we still keep it running. It's a horrible practice, but it brings in the bacon, so.
Anyone else? Okay, thanks.